Chapter 3 is all about polynomials, and we're going to start with section 3-1. One of the big things about polynomials that we'll be using a lot is the degree, which is the largest exponent of x. In the first example, they're going to ask you to find the degree of the polynomial. And so I said it's the largest exponent of x, so we would say that the degree of this polynomial is equal to 4. We also have a leading term, so this would be our leading term. So it's the whole thing with the numbers and the x's. And last but not least, we have the constant term. So the constant is the number that doesn't have an x. So in the next example, I'm going to have you find the degree of each of the polynomials that I give you. So basically, you just need to look at the largest power of x. So the largest power would be x to the first, so that you would say the degree is 1 for this polynomial. So for this one, it's x cubed minus 5x to the 7th. This isn't written in standard form, meaning the largest isn't first, but the largest power is x to the 7th, so you'd say the degree of this guy is 7. And this last one is a little bit tricky when it's f of x equals 5. There's no x term. This is the same thing as x to the 0, because anything to the 0 is 1. So we would actually say that the degree of this polynomial is 0. So the next thing we're going to be talking about is end behaviors of polynomials, how they end. So if you notice all of the exponents, the red graph is x squared, the blue graph is x to the 4th, green x to the 6th, purple x to the 8th. All the exponents are even here. So whenever you have even exponents, notice how they all end. They all end in the same direction. Here I have all odd exponents. So x to the 1st, x to the 3rd, 5th, and 7th. So these are all odd exponents. Notice how all the odd graphs end in opposite directions. So one ends on the positive side, one ends on the negative side. So we're going to be talking about the end behavior of polynomials, and basically what that describes is what happens at the endpoints of a graph. So we're going to be looking at the odd degrees, the ones that ended in the opposite directions, and even degrees. So let's start off with odd degrees. So we're going to have positive leading coefficients and negative leading coefficients. And here's what a graph would look like if you had a positive leading coefficient. So let's pick like x cubed, or something to the 3rd power. It has 3 directions. We'll talk about this in a little bit. And if you have a positive leading coefficient, what happens is that the end behavior, it ends up going positive on the right-hand side. So one thing to remember is you read a graph from left to right. So if it has a positive leading coefficient, it will end up going positive on the right side. A new notation is this. You're going to be writing this as x gets bigger, or as x approaches infinity, that little arrow means approaches, our y values also approach positive infinity. So as our x values get bigger, so do our y values. If I were to look at the end behavior on the left side, I'd say as x approaches negative infinity, so as our x's get negative, our y values also go negative. So y also approaches negative infinity. If you have a negative leading coefficient and its odd degree, remember odd degree means they end up in opposite directions, what will happen is your graph will look something similar to this. It ends up going negative on the right-hand side. So if you have a negative leading coefficient, it ends up going negative on the right side. So you're only looking at the right side. So how you would state this is as x gets bigger, so as x approaches infinity, here's your x values, your y values are actually approaching negative infinity. If you were to read the behavior on the other side, we'd say as x approaches negative infinity, so now we're looking at the negative x values, our y values would actually approach positive infinity. Now let's look at even degree polynomial functions. So when something's even, if you remember all those even powers, they ended up going in the same direction. So I'll do a graph that kind of looks like a W. This is even because they end up going in the same direction. Whenever you have a positive leading coefficient, you look at the right side of the graph and notice it's going in the ending in the positive direction. So if I were to do the same notation as before, I'd say as x approaches positive infinity, as my x's get bigger, so do my y values. My y's also approach positive infinity. You can put the positive sign if you like, or just leave it as infinity. Here on the left side, I'd say as x approaches negative infinity, so as my x's go negative, my graph goes positive. So the y values approach positive infinity. If I have a negative leading coefficient and I still have an even powered graph, this time my graph will end up opening downward. So looking on the right hand side, if I have a negative leading coefficient, it ends up going negative on the right hand side. So as x approaches infinity, my y values would actually go to negative infinity. As x approaches negative infinity over here, my y values also approach negative infinity because they're going downward. So before I give you an example on determining end behavior, I want to review a concept from Algebra 3. If you have a degree 3 polynomial, there is 3 directions on your graph. So here's what I mean by that. You have 1, 2, 3 directions. So this would be a degree 3 polynomial. If I have a parabola, which is x squared, you'd go, oh duh, that's degree 2. Well, on the graph, you'd notice that you have 1, 2 directions. That's why it's degree 2. So this graph right here, I know it's going to be odd because they end in opposite directions. So is it 3, 5, 7? What is it? So you just have to count the number of directions. So I have 1, 2, 3, 4, 5. So the degree is 5. The other thing is if I have a polynomial that looks like this, you could tell me 2 things about it. You could tell me that the degree, if I draw it, is 1, 2, 3, 4 directions. You could also tell me because it ends up going negative on the right side, it has a negative leading coefficient, what we just talked about. This also has a negative leading coefficient because it's going down on the right-hand side. These guys here both have a positive leading coefficient because they end up going positive on the right side. Okay, so now for example. So I want you to determine the end behavior of this polynomial, 8x cubed minus 7x squared plus 3x plus 7. Alright, first thing you need to know is the degree, because that's going to tell you how to draw it. And we're going to do this all without a calculator. So the degree is 3. We also notice that the leading coefficient is positive. So I'm going to put positive leading coefficient. Alright, so now what we're going to do is, since it's degree 3, we have 2 options. It's either going to look like this, 1, 2, 3, or it's going to look like this, 1, 2, 3. You've got to figure out from the leading coefficient which graph it's going to be. Because this is positive, we know it's going to end up going positive on the right. So this is going to be our graph. So then we just have to state the end behavior of that graph. And this is just kind of a generic graph, but all we need is the end behavior. So as x gets bigger, or as x approaches infinity, our y values also approach infinity. As x approaches negative infinity, our y values approach negative infinity. And that would describe the end behavior. So in this example, we know that the degree is 4 because it's the largest exponent. And our leading coefficient is actually negative. So when we draw our graph, we have 1, 2, 3, 4 directions it would look like that, or 1, 2, 3, 4. Which type of graph is it going to be to state the end behavior? Well, because it's negative, we know that it's going to be this graph. So that means that we are going to state the end behavior for this. So as x approaches infinity, so as x gets bigger, our y values get smaller. As x goes to negative infinity, our y values also approach negative infinity. Okay, so this completes part 1 of the notes. We're going to talk about shapes of zeros in the next segment, so go ahead and click on that video now.